Hey everyone, in today's lesson we're going to be looking at Unit 11 on sequences and series. This first lesson is on arithmetic sequences and series, and here's an example of a very famous arithmetic series at the top of this picture here. So our goal is to be able to write a formula for an arithmetic sequence and to find the nth term of an arithmetic sequence and to evaluate the sum of an arithmetic series. So first things first, what is a sequence? Well, a sequence is just a list of numbers that change according to some pattern. So you're going to have a sub 1, a sub 2, a sub 3, all the way to a sub n, and those are called elements um, of your sequence. Okay, a sub 1 is the first term, a sub 2 is the second term, a sub n is the nth term. Sometimes a sequence may start with a sub 0, but we're going to assume it starts with a sub 1 unless it's otherwise stated. So this is again Fibonacci sequence. It is a recursive sequence because it depends on what happens before it. So it depends on its previous term. So add that into your notes. Depends on previous term. Okay. So with the Fibonacci sequence, what you're going to notice is that if you add 1 plus 1, you get 2. If you add 1 plus 2, you get 3. If you add 2 plus 3, you get 5. So you're adding your current term and then your previous term. So here's some examples of some sequences, and we're just trying to come up with the next 5 terms. So here we go. We've got 1, 3, 5, 7. You should be noticing that that pattern is obviously an even pattern. So we're counting by 2s. So we'll have 9, 11, 13, 15, and 17 would be the next 5 terms in our sequence. The next pattern here, we see 6, 3, 0, -3, -6. So it looks like we are subtracting 3 each time. So we have -9, -12, -15, -18, and -21. So now we're given a formula for the nth term of a sequence, and we want to find the first 4 terms and begin with n equals 1. So we're just plugging in and seeing what we get here. So 4 times, so a sub 1 would be, and I'm just going to put it as a1. I know it should be a subscript, but that's okay. We're going to do 4 times 1 minus 3, so 4 minus 3 is 1. A sub 2, we would do 4 times 2 minus 3. 4 times 2 is 8, minus 3 is 5. A sub 3, we do 4 times 3, which is 12, minus 3, which is 9. And a sub 4, 4 times 4 is 16, minus 3 is 13. So there's our first pattern there. For our next one, we're going to do 1 minus 2, or n minus 2 squared. So 1 minus 2 is -1, and -1 squared is 1. 2 minus 2 is 0, 0 squared is 0. 3 minus 2 is 1, 1 squared is 1. And 4 minus 2 is 2, 2 squared is 4. So there's those first 4 terms. So a series is the sum of a sequence. And right here we have an example of a series. This is a Greek letter called sigma. It's capital Greek letter called sigma. At the bottom tells you what you're starting with. So I is our index of summation, where you're beginning. N is where you're ending, so that's your upper limit. This is your lower limit. And then your function is going to be right here. So what I have given you here is we're writing the series with summation notation. All right, so bear with me because I'm using my cursor here to write. So here's my sigma, not too bad. Notice we're starting with 3 is our first term, then 5, then 7. So we're definitely adding 2 each time. All right, but in order for us to start with the number 3, we have to get there somehow. So if we multiply 1 times 2, we get 2, and then we add 1, we get 3. Um, let's see if that would work. 2 times 2 is 4, plus 1 is 5, 2 times 3 is 6, plus 1 is 7. Yes, that'll work. So this is my, my function. So we're starting or with n equals 1, and we can go, all the way up as high as we want, but we only have 6 terms, so we're only going up to 6. All right, for our next one, we've got 1/4, 1/16, 1/64, 1 over 256. The denominators here are powers of 4. So 4 to the first, 4 squared, 4 cubed, 4 to the fourth. So what we have here, we're going to have 1 over 4 to the nth power. Okay, as our function part, and then we're going to start when n equals 1, and then we're going to go to the 4th term there. All right, so now we want to write this series out by summation notation and then evaluate. So I'm going to go back to typing now. So for this one, we're starting with 1, so 4 times 1 plus 4 times 2 plus 4 times 3 plus 4 times 4 and plus 4 times 5. All right. Then we're going to have 4 plus 8 plus 12 plus 16 plus 20, and we're just going to add those all up. So 4 plus 8 plus 12 plus 16 plus 20 gets me a total of 60. So there's the summation notation, or there's my series, and there's my answer. All right, so for our next one, I'm going to kind of do the math as I go along, so I don't have to keep doing any superscripts. So we're going to start with 1 plus 3 is 4, and 4 squared 16. 1 plus 4 is 5, 5 squared is 25. 1 plus 5 is 6, 6 squared is 36. And 1 plus 6 is 7, 7 squared is 49. And then we're going to add all of those up. So 16 plus 25 plus 36. Sorry, 16 plus 25 plus 36 plus 49. Gets me 126. Now, your calculators can do this as well. So you'll see on my screen and on your note sheet how to do this in a calculator. So to get the terms of a sequence, you go to second, stat, ops, and then 5. And then you're going to start with your formula, followed by your variable, followed by what you want to start with and what you want to end with. And then to get a sum, you have to get your terms first. So you start with the steps from above, and then you'll do second stat math 5, second negative sign, and enter, so that you can get your sum. And that's the sum of our first sequence that we did, our series that we did together. So what is an arithmetic sequence? It's a sequence with a common difference. We call that difference D. So whatever we're adding or subtracting every time is what the D represents. So if we look at our first sequence here, we got 3, 7, 11, 15. Each time we're adding 4, so our D is 4. All right, for this one, it's a little bit trickier to see because it's with fractions. So what you can always do to find your common difference is you can take a term and then the term before it, and you can subtract the two. So I'm going to take 9/4, and I'm going to subtract 7/2. Okay, so I want to get a common denominator first. That denominator is going to be 4. So 7/2 is the same as 14/4. Okay, so 9/4 minus 14/4 gets me -5/4. So that's what I'm adding each time, or you can think I'm subtracting 5/4 each time. That's my d value. So to find the nth term of an arithmetic sequence, we do have two formulas, and these are given to you on the formula sheet. If you're taking the SOL test, or if you were, taking a test involving this, you would have these. Our first is our explicit formula. I'm going to type that word out for you, explicit. For this one, you only need to know your first term and your common difference and what term you're trying to get. For the second one, that is another example of a recursive, like the Fibonacci sequence. So you have to know the term beforehand in order to find your next term. A lot of times we'll refer to that first one. So we're going to write a formula for our nth term for each arithmetic sequence, and then we're going to find the 43rd term. So if you look at this one, we got 20, 18, 16, 14. Pretty obvious we're subtracting 2 each time. So our d value is -2. So our formula, it's going to be a sub n, but I'm just going to put an for you. And a sub 1 is 20. Okay. And then we're going to add on n minus 1. And then we're going to multiply by -2. It's perfectly fine to leave your formula like that. If you wanted to condense it and make it a little bit prettier, you could distribute your -2 through. So that would get me 20 and then minus 2n plus 2. And then I could combine the 20 and the plus 2 to get 22. So my formula would end up being 22 minus 2n, or -2n plus 22. Now to find our 43rd term, we would just have to plug in 43 where we see the n. So 22 minus 2 times 43. 2 times 43, of course, is 86. So 22 minus 86 gets me an answer of -64 for the 43rd term. Here's our next one. So we got 0.2, 0.7, 1.2, 1.7. So it looks like we're adding each time 0.5. So that's our common difference. That's our d value. Okay, so my a sub n formula, I start with my first term, and then I add on n minus 1 times 0.5. I can again distribute that 0.5 through, and I would have 0.2 plus 0.5 n minus 0.5. And of course, 0.2 minus 0.5 is 1.5 plus 0.5 n. So there's my formula, and then my 43rd term, I would have to do 1.5 plus 0.5 times 43. So 43 times 0.5, and then we add on 1.5, we'll get a total of 23. Okay, and then one more. So feel free to pause at any time and try this on your own, see how you do. So you should notice that you're adding 11 each time. So that's our d value. So our formula is going to be 2 plus n minus 1 times 11. If you wanted to condense that, 2 plus 11n minus 11. So we're going to end up with 11n minus 9 as our formula. And then our 43rd term is going to be 11 times 43 plus, or sorry, not plus. So 11 times 43 minus 9 is 464 is our fourth term. All right, so now finally we're going to talk about arithmetic series. So that's going to be the sum of an arithmetic sequence. Again, there are two formulas here. We're going to primarily work with the first one, and both of these are given to you on your formula sheet. So this s sub n is going to be your sum. You do your n minus 1 times 2 times your first term, a sub 1, plus n minus 1 times your common difference, d. Again, this is the explicit, this is the recursive. So you need to know implicit. This, you would need to know your final term in order to do that. All right, so we're going to find the sum of the first 10 terms, and I'm going to do myself a favor here I'm just going to copy this onto this next slide so I can see it. All right. So what we're going to do, we're going to find our first 10, or sum of our first 10 terms. So that means we're going to do 10 divided by 2, okay? And then we're going to multiply 2 times our first term, 20, plus 10 minus 1 times our common difference. And this time you'll notice we're going down by 2. Okay, so a lot of this is pretty basic math. So 10 divided by 2 is 5. Okay, 20 times 2 is 40. 10 minus 1 is 9, times negative 2 is negative 18. All right, 40 minus 18 is 22, and times 5 gets me 110. So for our next one, we are increasing each time by 10. So again, we're going to find the first 10 terms. So I already know 10 divided by 2 is 5, so I'm just going to put that there. 2 times my first term, 2 times 15 is 30. I'll put that there. 10 minus 1 we know is 9. Okay, and our common difference here is 10. So 9 times 10 is 90, plus 30 is 120. So now I just need to do 5 times 120, which should get me 600. Okay, my next one, it looks like I'm adding 20 each time. Again, feel free to pause and try one on your own. So we're doing the first 10 terms, so we're going to start with 10 divided by 2, which is 5. 2 times our first term, 118. And then we're going to add on n minus 1, so that's 9. And then we're going to multiply by 20. So there is our problem. So 2 times 118 is 236. We're going to add on 9 times 20, which is 180. And then we're going to multiply that, which is 416, times 5 to get a total of 2,080. All right, so here's one final problem for us, an application problem. So we have a marching band formation that consists of 6 rows. The first row has 9 musicians, the second row has 11, the third has 13, and so on. We're trying to figure out how many musicians are in the last row and how many musicians are there overall. So to figure out the amount in the last row, that would be a sub 6. So I'm going to go back to when we talked about that formula, which is right here. I'm going to copy that formula and put it on my slide so I can have it right in front of me. Okay, so we want to find the 6th term, right? So our first term was 9, and then we are finding the 6th one, so 6 minus 1. And then our common difference, so we went from 9 to 11 to 13, so we're adding 2 each time. So that's 2. 6 minus 1 is 5, and 5 times 2 is 10, and 9 plus 10 is 19. Okay, there's not that many rows, so it wouldn't have been that difficult for us to figure out by hand. But say, we had 200 rows. We don't want to keep having to do that the whole time, so this is very handy. All right, so now we're going to do our summation. So I'm going to take this. Again, finding this by hand would not be too terribly difficult, but we're still going to do it. So, all right, so here we go. We're going to use this formula right here. Granted, we could use our second formula because we do know a sub n, but we'll continue using that first formula because that's what you're going to be using on your classwork assignment today. So we know 6 is what we're trying to find, divided by 2 is 3, and then we're going to multiply by 2 times our first term, which was 9, and then we are doing 6 minus 1, which is 5, and our common difference of 2 is what we're multiplying by there. So 2 times 9 is 18. 18 plus 5 times 2, 10 is 28. So now we just need to do 3 times 28. And 3 times 28 is 84. So primarily what you're doing for your assignment today is going to be using this first equation here, which is on your notes now, and now we've worked with it and practiced with it. So what I want you to do, you're going to get a copy of the worksheet, and you're going to work through each of the problems. I want to see your work, okay? And then I do want you to color. There are colored pencils in the wire uh, bookcase type thing on the side of my room. Feel free to use those. Um, and, finish it. If you don't finish it in class, finish it for homework.